All right, let me talk through this. Again, you can use either method, method 1 or 2 for this. It's pretty much set up to be solved efficiently either way. If you treat this as method 1, that means we're going to treat the numerator as one single fraction and the denominator as one single fraction. Now again, notice, anytime I don't actually have a fraction, it may be useful to write it over 1 just so you see the relationships that exist. And if we work just in the numerator, we need to find an LCD for both of these fractions. So we need a 1 and a factor of y. So our LCD factor is just the y. Take the numerator's first term, or the first term's numerator y, multiply that by the LCD factor missing from its denominator. What's it missing? So y times y is y squared, plus the next fraction's numerator times what LCD factor is missing from its denominator? Nothing, just 1, so you can leave it as it is. And we're going to divide that by y squared. And again, writing it over 1 can help because when you invert and multiply, so instead of using division, we're going to convert it into multiplication. So the y squared gets moved to the denominator, the 1 gets moved to the numerator. Now here's where this comes into play, because a lot of times during this step, if you didn't write this as a fraction, what a lot of students think is when they invert and multiply, where is the y squared located in the whole fraction? It's in the bottom, the denominator, right? And so a lot of students, when they invert and multiply, might think, well, it was in the denominator, now we're moving it into the numerator. Okay, you don't want to think that way. What you need to think is, as a whole fraction, the y squared is in the numerator of this individual fraction. So when you invert, you have to move it to the denominator. So just be careful with that. It's a source of confusion, potentially. Okay, so you multiply across the top, across the bottom. There's no common factors that can cancel. And so that's your simplified form. Okay, now, were there any domain restrictions that you need to account for? Again, the only one was that y can't be 0. That's shown in the simplified form. Again, y squared can't be 0, so y can't be 0. Already shown that.